Hey guys, Ray here. Welcome to the channel. Today I'm excited because I am installing these 540 watt massive solar panels in my backyard. So this should be a fun video. I'm going to go through all the steps to building the array that I'm going to be using, the racking system for these panels, the trenching, all the wires, and I will be installing an all-in-one power system and battery that will be running my main electrical panel in my house. I am going to have this system inspected by the city, so I'm going to be very careful to try and obey all of the safety rules and regulations there. But I'm going to go through all the steps, so if you want to have some fun, come along. This video is divided into sections, so feel free to jump around. So I am getting help from my neighbor that's an electrician. I am not an electrician, and this is not a how-to video. This is simply documenting the progress I am taking in installing the system. I am definitely open to any feedback you guys have. If I do make any changes based on your feedback or based on the feedback from the inspector, I will document all those changes in the description. Okay, I had my neighbor come out and help me dig this trench. I want this trench to be 18 inches deep. I want my pipe to be 18 inches deep. And I cleared out all the grass and realized I'm gonna need a trencher because this is just killing me. So I ended up renting this 18-inch trencher from Home Depot. It wasn't too expensive for the amount of time that it saved, but I think I should have got the 24-inch trencher, which was this one, because it came with a trailer and it really wasn't that much more expensive. Then I could just guarantee that my pipe is 18 inches deep, because with that 18-inch trencher, the top of my pipe was really about 16 inches deep. Made sure to call Blue Stakes to make sure I wasn't going to hit any electrical lines. So in the future, I might have a ground array out to my external garage here. And so I'm just digging an extra trench for that ground array. But this is where we're going to put our solar array in today, right against the fence. So I have one conduit here, and then it'll combine and there'll be two pieces of conduit in this final trench here. And we're just cleaning out this trench because it wasn't quite deep enough. So both of the conduits are going to combine next to the brick there and go into one conduit. And it'll go into the attic, down the wall, and then out to where my inverter is. I'll show you that later on in the video. So here's all the wire I got from my electrical supply store. I'm just measuring it out so I have all the different lengths correct. My wife, bless her heart. So I'm going to have a total of 14 panels in this solar array. So I'll have one string of 7 and another string of 7. Now each solar array string is going to have its own dedicated wires into the inverter. Now I'm using number 8 wire because I might want to add an extra set of panels in the future, and that way I can combine them into parallel. If I wasn't going to run them in parallel in the future, I think I would probably just stick with number 10 wire for this. For measuring distances, I've noticed that Google Earth is surprisingly very accurate. So I just pretty much set 2 chairs out 175 feet apart, and then I can run this wire between the 2 chairs and have a perfect length of wire for my run. So I was able to get the conduit all in the ground, and now I just need to pull the wires through the conduit. The electrical supply company also got me this bowl line measuring and pull tape. So it's thin enough that it can pull through the conduit, and it's thick enough that it won't heat up and tear through the side of the conduit as it's pulling through. You can see there's different length markings by the foot, so you can see how much line you're pulling through your conduit. Wow, look at that. Okay, I've hooked the string to the wires. I have one 8 gauge cable here, and then it goes into 2, then to 3, and then all the way to the whole group. So I got 2 8 gauge wires for each run of solar panels. I got a ground, and then I've got a 12 gauge wire. This is going to be just for if I want to test some solar panels on the ground here, maybe I'll use this, maybe I won't, but I'm just gonna pull it through right now. This is actually really easy to pull. I'm having my 10-year-old son pull it from the other end. Told him there's a prize at the end. Find the prize? Okay, keep going. What'd you get?
A wire.
Yeah, got it. Nice job, bud. Here I'm bringing out the troops. We are just burying the line. That's right, my grass is not going to die. I actually had the city inspector come out and look at the trench. I had a separate permit just for the trench, so I can bury the grass back or put it in place so it doesn't die. My wife was happy about that. You may have to check with your inspector, but he might allow you just to stick a pipe in the ground and then bury your trench, and then when he comes over to inspect your whole system, he can look in the pipe to see how deep your trench is. Okay, these are the solar panels. These are about the largest solar panels I could find because I'm going to have one long array of solar panels in the backyard here. So I wanted the biggest ones I could find. They are 540 watts. Now, this is the front side only, but they are bifacial solar panels, so they will pick up power from the backside as well. So I think these can go up to maybe even 640 watts with this panel. Now, I picked these up from SanTan Solar. Now, SanTan Solar, I usually get used solar panels from them, but they have been stocking new solar panels as well. I couldn't find used solar panels this big. I think these are listed on their website right now for $189, but that price may go up because tariffs on solar panels. So I don't know what the price is going to be for these. They might go up quite a bit, but we'll have to see about that. I'll put a link to these solar panels in the description and a discount code. So I should have discount codes for the battery and the inverter system as well. And those should work if you use the links in the description. I'll also try and include Amazon links to all the different smaller components that I use. Let me know if I miss anything. Okay, this is the racking system I ended up going with. So one of the reasons why I had solar panels in my backyard sitting for so long next to my fence is I was really just dreading installing the racking system. I didn't want to rent heavy equipment to drill holes in my backyard. I didn't want to install cement pillars and make this large mounting system in my backyard just for the solar panels. Yeah, it just seemed a little bit overwhelming. I do have a back garage that I could put some solar panels on, but I think in my specific area, I need to have a rapid shutdown system installed if I put solar panels on the roof of a building. So really a ground array did seem like the best, easiest option for me. So I was looking at ground racking systems from other distributors, and the install time for just a simple rack of maybe 4 panels was like 3 hours to assemble. And then I saw this racking system, and there's literally 2 bolts per frame to install. So it's super easy. I think this is called a ballast mount, where you literally put the frames on the ground and then you hold them to the ground with weight. You can put jugs of water on there if you have or if you have a skid steer, they have a like a sheet of fabric that you lay down, and then you can put dirt on there to weigh them down. So I ended up using the spike system. I have hard clay in my backyard, but probably don't want to use those spikes if you just have straight sand. But the spikes could be used in addition to the weights. The theory here is this is not a permanently installed structure on my property, similar to the blocks holding my solar panels up. Now, the hardest part of setting these solar panels up was making sure they were level. So this is the right side of my array, and there was probably a 15-degree angle of slope. And then on the left-hand side of my array, there was probably only a 5-degree angle of slope. So I didn't want my entire array to kind of slope. I wanted it perfectly level. So I use this, I think it's called masonry string, to make sure all of the tops of the frames follow this string. And I live at latitude about 40 degrees in Salt Lake City, near Salt Lake City here, and so I want my solar panels to be faced about 40 degrees because I'm not going to be adjusting them. So that's the ideal slope for my solar panels in my specific area. Here's a little bubble level app I downloaded just to make sure I have the exact perfect slope. Obviously they are facing south. Yeah, making these level was definitely the hardest part. I have a little bit of OCD, I think, so probably don't need to spend that much time leveling these as I did. So after I got them level, you buy this 1-inch EMT conduit, and it slides in between each of the panel frames to make sure they're separated. And then there's a set screw that goes in between the frames. And each 1-inch piece of EMT overlaps slightly. So some frames will have 2 pieces of EMT in there. So obviously you got to make sure that each frame is spaced exactly the width of the outside of your solar panels. So before you set that set screw in place, and when it has to be in place, I want to make sure everything's level as well. So this is where my OCD really kicked in. I wanted to make sure everything was perfectly flat. So I moved the entire array out to the street where the street was perfectly flat. This is all aluminum, so obviously it's pretty light. Then I could set all of these set screws and get the spacing perfect.
Yeah, these are going to go next to the back fence. Yeah.
Let me know how it works.
Okay, will do.
Good. Oh, somebody stepped in the poop.
Oh, sorry, was that you?
Look out for those ones. Oh, there's a giant one right here, Tim. Holy cow.
These spikes also come with an epoxy that you put down the hole, and then it spreads out and holds the stake into the ground. I didn't get a video of me mixing the epoxy and pouring it down the hole. I think I hammered these in a little too far. I think the manufacturer told me to maybe leave 4 to 6 inches. Now I did hit a few rocks when I was putting these last ones in, and the hammer drill didn't quite get the rocks out of the way, so I ended up bending a few stakes. So I might need to call the manufacturer and get a couple replacement stakes. So here is the piece that connects the frame to the rack. Now there's a sharp tip at the end there I showed, and that will electrically bond the frame of the solar panel to the racking frame. You just slide it into this groove here, and then line everything up. You can tighten it down. They supply this wrench with your kit. I marked the side of each frame so I know exactly where to put each bolt. And then usually bring them all in. And I almost had to get a stool because you had to reach over and tighten up that middle bolt. All right, wow, that is pretty big. It is all in. I've got one problem though. It's gonna bug the heck out of me. It's very straight except one little high spot right there. I don't know if you can see it. So I need to dig down. I think it's that frame and make it a little bit lower. So it should be easy. I just have to loosen this and then dig underneath it, get it a little bit lower, then I can tighten this again, and it'll hold tight to the stake here. There we go. That is close enough for me. So remember, underneath my solar panels, this wire is just hanging out here. So I'll show you at the later on in the video how I'm going to clean that up. But let's first jump back to the side of my house where this solar wire is coming out of the ground. Now I'm saving a lot of money by not having microinverters connected to the underside of my solar panels. So instead of having AC, I do have DC coming into my main inverter in the house. Now with that, the National Electric Code requires any high voltage DC power, DC wires to be enclosed in metal on the outside of your house and also inside of your house. So that's the next step I'm going to do here. Now I'm going to be using 1¼ inch metal flex to run through the attic and down also into the wall, and then it'll stub out near my inverter. Now I believe most electricians use fish tape to pull their wires through metal flex, but I don't have that, so I'm just going to be using my regular vacuum and pull tape here, or bowl line. Now this is a 50-foot length of flex and it is not airtight, so I needed to straighten it, and then I just had just enough suction in order to suck my pull tape through. Oh man, oh this sucks bad. So remember, I have PVC in the ground, and as I come up, I need to transition over to metal. So I'll transition over to metal EMT, and as I go into the attic, I'm going to transition to metal flex. That's why I'm building these junction boxes. This is going to be outside near my sprinklers, so I want to make sure I'm using Myers hubs and waterproof connector fittings. Now this is EMT. Now if I was in a driveway or an area subject to physical damage, I wouldn't be able to use this. I would want something thicker, like the rigid metal conduit. Okay, so here I am preparing for possible future solar arrays. So I'm just going to run some extra wires here out to my external garage. And I'm going to run them in 1-inch conduit here because I might have 2 arrays on top of that. Also, I have an RV that's parked on the side of my garage there. Now I have 1600 watts of solar installed in my RV, so I don't want to waste that. So what I think I'm going to do is I'm going to, once I park my RV, plug my RV into my house, my solar, and then that'll save me money on my electric bill. That will probably be a future project. But there's a boatload of wires coming through. Okay, I'm about to pull all these wires through here, 14 total, through that, through the attic, down inside the wall, and out where my inverter is gonna go. Now there's another YouTube channel called Electrician U, and he's got a really good video on calculating how many wires you can legally fit into your conduit. So I followed those calculations and I am legal here. So I was really worried that I wouldn't be able to pull all these wires through. So I had to double wrap the twine there. And at the tip of my wires where I started to pull through, I really only had maybe 1 or 2 wires. And then as it got thicker, I added more of the wires until they all came together at the end. It was kind of a pain. I had to cut out part of the wall here to feed it down. Go ahead. Here we go. Okay, hold on. Okay, this is my original install. I'll put a link on the top to that original install where I slowly go through installing it and then testing it with my house. For this video, I'm going to be installing a new system. Okay, I really liked this battery bank, except my inspector is not going to like it sitting in front of my electrical cabinet. I think that I need like a 30-inch space around my electrical panel. I can't remember the exact measurements, but this is definitely getting in the way. So I would have to move this over here, and then it would get in the walkway. I wish I could use this space in the corner because this cabinet would be perfect. They even have a 10 battery cabinet rack. These are self-heating and they're really affordable. So I'm going to use this battery. This is from my off-grid EV car charger. I never got an EV car. My minivan is just too tempting to keep around with 5 kids. EV car in the future, for sure. Okay, right now my house is running on the grid, but when I have my inverter connected here, I have my wires coming up and they're going to feed in through here through this 60 amp breaker. So if I want to go off solar, I need to flip this. This whole thing slides up and will allow me to turn on the solar. So this black and red wire here are going to connect to the output of the inverter and they will hook it right into here. Now this is 6 gauge wire, so if I look at my wire chart that I found online, 6 gauge should be able to support 70 amps. But I have a 60 amp breaker, so anything over 60 amps, this should trip, so it should protect this wire here. And then I have my ground and my neutral that will connect to ground and neutral. And these are going to connect to the neutral and the ground on the bus bar here. And the 6000 XP inverter also allows grid to be connected in case the batteries are low. So here I've tapped into the grid power. I'm going to hook that into my grid connection. So you notice the grid connection doesn't have a neutral. That's because the manual states that you can have a shared neutral for the system. I believe I could add an extra neutral wire for my grid, but then I'm going to have pretty much 2 neutral wires connecting to the same bus bar on both sides. Really, it's way easier just to call an electrician, have him wire this up for you. It's not going to take him that long, and he's going to make sure you're following your local rules and regulations, and he's going to make sure you're safe. So if I have a storm and batteries are low, it'll pass the power through here, up through here, and in there. Now those are also 6 gauge wires that can support 70 amps. And they will hook into the grid. Now this is a 50 amp breaker, so anything over, so if this thing tries to draw more than 50 amps through that 6 gauge wire, this should protect that wire. I am going to increase these wire sizes so they will be protected by the 100 amp breakers that are near my meter on my house. Wow, that was lucky. Here are my grid wires. Notice if I move them back and forth after I tighten them, this allows me to get a few extra cranks on there. All the torque specifications are in the manual. I'll provide a link to this crimping tool and lugs that I used. The manual states if I have fine stranded wire, I should use ferrules. This isn't fine stranded wire, but I'm just going to use these ferrules anyways. So I'm loving the way that this array looks in the backyard. So the next step, I just need to clean up the wires as they come out of the ground and connect into the solar panels. Okay, this is probably the most popular way of doing it. This came from Johnny Valentine. He does system installs in Georgia, but basically involves this junction box that will accept the solar panel wires from the ground. And then there's a weatherhead up top that will accept the solar panel wires from the panels. And then they go into a IMO disconnect here. And the IMO disconnect is connected to the box with a simple waterproof Myers hub and chase nipple. Yeah, my box does not have the IMO disconnect at the top here, but I might add it later. It does, however, have some extra safety features that this box doesn't have. They could be overkill, but I like having extra safety, and I'll show you those. Okay, I'll show you a little bit about this box, why I like it, why I decided to go this way versus the traditional route. So I got this box from Watts 24/7. This was, I think this would cost me just over $200, which was a pretty good price, I think. Here's the specifications on the box. So it makes these combiner boxes in all different types for you, but this one is called the 4-2, so it takes 4 strings and reduces them down to 2 strings. So right now I just have 2 strings here, 7 panels and 7 panels. So I'm just going to use, I'm not going to actually use the combiner box at all, but I will just keep these 2 extra ports open if I want to add some extra strings in the future. And I've got 8 gauge going into the house, so I should be able to run 2 strings in parallel on each of these lines here. So just show you how this works. So the solar comes in here and it goes into these fuses. There's a fuses for the positive and negative. So this is a 15 amp fuse. I'm a little worried that I'm going to be blowing these fuses because my panels are so big. They operate at 13.2 amps maximum. So if I have any troubles with these, I will let you know. And it comes in here, goes through these diodes just to make sure the power is only going in one direction and not going to backfeed. Then it goes into the surge protection here. From the surge protection, it comes out the bottom here. So I'm going to have my positive and negative, and I'm going to have a positive and negative here. Now, if I went the other way with just a shut-off switch, I'm not going to have any of these fuses, I'm not going to have the diodes, and I'm also not going to have this surge protection. This is outdoor solar wire I just ordered on Amazon. Now I made sure this connection is disconnected down there, or I'd be able to measure about 400 volts between these 2 terminals, and I don't really want to get hit by 400 volts today. Now I had to make this 1.5 inch hole with a hole punch that I had, and that was fine, but these all come with it. Once you tighten it, it'll cinch around the wire to make everything watertight. Pretty nice. For my grounding, I have this lug connected to the frame of one of my solar panels. They're all connected. And for this lug, it's going down and running into the house earth grounding system. My inspector may want this just go to a local grounding rod next to my panels here, but I'm glad I ran this ground wire just in case he wants it to run all the way into the house. Okay, it's all cleaned up. I got the zip ties all put on. Looks so good. Glad it's all put together. Let's try it out. It's all put together here as well. Okay, I added this communication wire and those battery settings there. And that will send the battery percentage details up to the inverter, so I can have that information on the app. Solar, grid in, load out, and then the battery. Okay, let's first turn on solar. Okay, that's awesome. Okay, let's turn the whole house over to solar battery. Turn it off the house right now. Here we go. Now, if there's a long storm and the battery goes dead, grid power should automatically pass through and just continue to run my house for grid backup. Here is the app. This is how much power my entire house is using right now, and this is including the 3-ton air conditioner. So pretty awesome. I think these panels are like operating at 90% right now. It's super sunny right now. So I really like the large solar panels and the simplicity of having a single row of solar panels with that racking system. If they run out of stock with these specific panels, they said they're going to get a bunch more in that are really similar in size. So if you shop around there, you should be able to see some. Of course, I'll leave a discount code to the panels and this system as well. I'm excited to try out some different inverters. But if you want to see a slower install of this system and testing it on my house, I'll put a link to a video right here. And if you want to see 2 months worth of testing data with this system, I'll put a link right here. But thanks a lot for watching, guys. We'll see you guys in the next one.